we'll look at an X-ray diffraction plot for powder diffraction or X-ray diffraction. The plot would be such that you will not have these Miller indices marked for your peaks. You'll have a plot, and we'll try to uh, solve out that X-ray diffraction plot in order to identify the Miller indices, the crystal structure, the lattice parameter, the atomic radius, and the element itself. So this is basically the X-ray diffraction plot that you'll have to be working on. Now, as I mentioned earlier, that in X-ray diffraction, the source is what? The X-ray source is what?
Metal.
It's metal, which is copper. Copper is being used. And copper X-rays that are being used for X-ray diffraction, they have a fixed lambda, and the value of lambda which is fixed is 1.540562 angstrom. What is angstrom?
Multiply 10 cube
10
minus
is
10.
power minus 10.
10 is to minus 10 meters.
10 raised to power minus 10 meters. All right. So this is the lambda of X-ray that is being used. All right. Now, when you see the X-ray plot, you will not have these peaks marked. You will just have the pattern as it is shown to you without any demarcation of the peaks. But you can essentially read the value of 2 theta by placing the cursor on top of this line. So for your ease, because this angle needs to be very carefully measured, uh, correct to 2 decimal places. So the angles are already written for you. What you have to do is you have to complete a table that would help you identify the Miller indices, the crystal structure, the lattice parameter, and the interplanar distances, as well as the atomic radius. So the first thing is that when you have the pattern, you have to index the pattern and determine the lattice parameters. What are the steps? You have to identify the peaks. Obviously, that is the first thing that you have to do. Determine the sine square theta, calculate the ratio of sine square theta minimum, multiplied by appropriate integers. We'll come to know what is meant by appropriate integers. Select the result that yields h square plus k square plus l square as an integer. We'll see what is meant by that. And then you'll have to compare the sequences of h square plus k square plus l square with a table to identify the Bravais lattice, or uh, uh, you have to find the HKL, and then you have to calculate the lattice parameters, and further on you have to find the atomic radius. So let us look at the table that we have to work into. So you should have your calculators with you, and have this table with you so that it's easier to solve the table. So first thing is you have to identify the peaks. There are altogether 8 peaks. So I have written 1, 2, 3, 4, 5, 6, 7, 8 peaks, and the 2 theta angles, they are also being calculated from that, or identified from that X-ray diffraction plot, and they are written for you. 38.43, 44.67, 65.02, 78.13, so on and so forth, and it goes up to 106.36. You have 8 peaks having different 2 theta values that have been identified for you. Now, the first thing that you have to do is you have to find out sine square theta values. So I'll give you, let's say, 5 minutes to find out all the sine square theta values for the corresponding 2 theta angles, and then we'll fill up this table. So first thing, find out the sine square theta values. You have 5 minutes, and then we'll fill up the table. All right. So kindly find out the values, please. Are you guys with me?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
All right. Please find out the values, and then we'll fill up the table. Just for the first column, which is sine square theta. Once you have found out the values, please do let me know so that we could start filling up the table. G, what's the status? Have you found out the values?
Yes, sir.
All right. So let's start filling up the table. So what is the sine square theta value for the first peak?
Sir,
Sir,
0.386.
0.108.
Sorry,
0.108.
0.108. Yes, sir.
0.108.
Yes, sir.
Now it's essential that you find out the values up to uh, at least 4 to 5 decimals.
It's 1083 then.
10833.
Yes, sir. No, just 1083.
All right, chalo, let's see. What is the second value?
0.14.
1 for what?
Sir, 1444.
All right. And the third peak?
Sir, 0.2888.
0.2888. Fourth peak?
0.288, sir.
0. Point?
0.397.
Sorry.
39. 0.7, sir. 397.
39.
All right. Fifth peak?
0.433.
0.4330.
Not sure.
Triple P.
Sixth peak?
Sir, 0.5776.
0.577.
6.
All right. Seventh? G.
0.6859. 59, sir.
All right. The last peak?
Sir, 0.722.
722.
7.
220.
All right. Now, once you have found out the values for sine square theta, what you have to do is that in this column, which says 1 multiplied by sine square theta over sine square theta minimum, you have to look into the first column and find out the minimum sine square theta value. What is the minimum sine square theta value?
Sir,
0.108.
1083. So you have to divide every value in the sine square theta column by 0.1083 and write it down in the column which says 1 into sine square theta over sine square theta minimum. So you have to divide every value in this column by 0.1083 and write it up in this second column. The first value would be 1 and the corresponding values you would have to dictate me one by one. So what is the second value?
Second value है
1.3.
1.3333.
Sorry,
0.3.
सर 1 पॉइंट आगे 3 लगाते जाएं जितना लगाने.
We'll write up to 4 decimal places. All right. Now the third,
2.6667.
2.67.
oh, fourth value,
3.6657.
4.0009. 4.0009.
1.009.
sixth value, what is the sixth value?
Sir, 5.334.
Seventh,
6.3333.
and the last value,
6.667.
6.667.
Yes.
All right. Now you have to fill up the second or third column by multiplying these values, the values you have found out in the preceding column, you'll multiply the values by 2. So the first value would become 2, and then the preceding values would be
2.6666.
third,
5.334.
5.334. Fourth value,
7.3314.
G. Fifth value,
8.0018.
sixth value,
10.6668.
10 point,
6668.
seventh,
12 point tetra 6. 0.6666.
last value.
Sir, 13.3334.
All right. Now, this would become the deciding stage. This column, where you have multiplied the values by 2, this would become the deciding column whether you have to go and multiply the values by 3 or whether you have to fill up this h square plus k square plus l square. Now, if you look at the values in the column where you have multiplied the values by 2, if you see, are these values in whole number or almost the whole number? That is the deciding criteria. If all the values in this table, for all the peaks, if the values are whole number or almost the whole number, then you would not multiply the value by 3 and directly round off the values and write the whole numbers in this h square plus k square plus l square column. But let's see and multiply the values by 3 and let's see the difference between the two columns. So what you do is that multiply the values by 3 for this column, the values that you have found in 1 into sine square theta over sine square theta minimum, you multiply the values by 3. So the first value would become 3 and the preceding values, could you,
Sir, 7.9998.
you don't have to multiply the values in the second column by 3. You have to multiply the values in the first column by 3. So you'll multiply 3,
3.99.
all right. And this value, the third peak value,
8.0001.
the values for the fourth peak,
10.9971.
all right. The fifth peak,
12.0027.
The sixth peak,
16.0002.
18.9.
and last value,
20.031.
all right. Now you have to compare the values in the second column and the values in the third column. What do you think? Which of the two columns have values which are whole numbers or almost the whole numbers? Which of the two columns have all the values?
Third
So
column.
third column.
Third column.
एग्जैक्टली जो थर्ड कॉलम में वैल्यूज है या वो होल नंबर है या वो ऑलमोस्ट होल नंबर है फॉर ऑल द पीक्स. सो यू हैव टू सिलेक्ट वन ऑफ द कॉलम्स जिसमें या वैल्यू होल नंबर हो या ऑलमोस्ट होल नंबर हो. जो भी कॉलम आप सिलेक्ट करेंगे you would round off the values and write down the values in the h square plus k square plus l square column. All right. So if I see that third column has almost all the values as the whole numbers, so I'll round off the values and write in the h square plus k square plus l square column. The first value would become 3. The second value would become what?
Sir, 4.
4. Very good.
Four.
Third, 8,
8, sir.
and then
11,
11,
11.
12,
12.
12,
16,
16.
9.
9,
9.
It's basically 18. 18.999. One has got
19.
19.
10.
10.
20. 20.
20.
20. Very good. So now you have got all the values as whole number in h square plus k square plus l square column. What you have to do is that you have the values of h square plus k square plus l square. Now you have to go see a chart and compare these values to find out HKL indices. How do you do that? You have this chart with you. In this chart, if you could dictate me the values for the h square plus k square plus l square column, the values were 3, 4, 8, and what were the the following values? Sorry,
12. 11.
sorry, just give me a minute. So 3, 4, 8. Then there was 11,
Yes, sir. 12.
12,
16.
16,
19.
19,
And then 20.
and then 20. So you have these values with you, which are h square plus k square plus l square values. Now you will compare the values. You see here it is written h square plus k square plus l square, and just beneath it, it is written HKL. So if my sum h square plus k square plus l square is 3, the peak it would represent would be the 111 peak. So I'll write for HKL column, I'll write 111 over here. Clear enough?
Yes, sir.
For the second peak, for which the sum for h square plus k square plus l square is 4, what would be the Miller indices?
So 200.
200. For 8,
So 220.
220. For 11,
311. 311.
311. And for 12, 12 would be what? Sorry?
322. Sir, 322.
12.
222.
Triple two, yes. 322 is something else. Then 16.
400. 400.
Very good. 19.
331.
331. And for 20, it would be
420.
420. So you have now identified the Miller indices for the corresponding peaks from 1 to 8. Clear enough? Is the process clear enough?
Yes, sir. Sir, we have to memorize these values of 1 at 1 and 2 and 3.
No, this chart would be given to you. All right.
Okay, sir.
All right. Now, so if you could dictate me the values for HKL, 111, 200, 222, 311. Then the value is what?
222.
222, sir.
सर ऊपर जो आता है ना वो 220 आता है 8 के सामने से 220.
Sorry, yes. 220, yes. This would be 400, and 19 would be what?
सर 331.
331, and this would be 420.
Yes sir.
You have
Yes.
identified the Miller indices. Now, how do you find the lattice parameter? जी
सर वो सर थोड़ी सी लाइट चली गई थी सर, ये जो लास्ट कॉलम आपने फिल किया है इसका थोड़ा सा दोबारा गाइड कर देंगे?
You would go to this chart. You have the values of h square plus k square plus l square with you. So for any h square plus k square value, let's say your value is 3. So the corresponding column or row would give you the value of HKL, that is 111. Similarly, for 4, it would be 200. For 8, it would be 222. All right. So that's how you fill up the column. Now, if I write down the values, GG.
सर उस चार्ट में सर वो वैल्यू ऑफ 9, 17, 18 सर आई थिंक सो
कोई भी पीक ले सकते हैं, कोई भी पीक ले सकते हैं, 300 भी ले सकते हैं, 221 भी ले सकते हैं. Alright?
यस सर.
Now let me write down the values again. For the peak 1, the value was 111. Then for the second, it was the value was 200.
200.
For third, it was 220. For fourth, what was the value? 311.
Yes sir.
Yes sir 311.
For fifth,
Sir 222.
222. For sixth, 400.
400.
For seventh,
Sir 331.
331. And for eighth, it was 420.
420.
All right. Now, in order to identify the crystal structure, whether it is FCC or BCC, you would use only for FCC and BCC, the difference between FCC and BCC. You have to use this criteria that is given to you, reflections present. And for simple cubic, all the peaks would be present. Don't worry about it for the moment. First, try to understand what is the criteria for FCC. For FCC, every peak should satisfy this criteria, that H, K, and L are unmixed. Unmixed means either all the three indices H, K, and L, either they are even or they are odd. This is the criteria. Clear?
Yes sir, clear.
All right. So now the material, for the material to be FCC or BCC, अगर हम कह रहे हैं कि material FCC है, so every peak should satisfy this criteria of HKL unmixed. If any single peak does not satisfy this criteria, you cannot say that the material is FCC. Is this clear to you guys?
Sir आपकी आवाज नहीं आ रही सर सही.
Yeah. Is it the problem with everyone or is it the problem with you only?
Yes sir. इस टॉपिक में आपकी आवाज का थोड़ा सा मसला हुआ है यहाँ पे आके, डिफ्रैक्शन रूल्स इन क्यूबिक सिस्टम पे.
Let me try to see if there's any other connection available. All right. Is the voice better now? आवाज बेहतर है कुछ?
Yes, no, sir. अभी बहुत लैग हो रही है.
सर ये पहले वाली ठीक थी.
पहले वाली ठीक थी, अब लैग हो रही है.
जी. इससे पहले वाली भी ठीक थी.
Let me try to connect. I don't know what's the problem over here. Anyways,
सर अभी आपकी बात सही आ रही है.
Yes.
all right. Can you guys hear me?
Yes, sir. Now.
Yes, sir.
अभी बेहतर है?
Yes, sir. Now
Yes,
is okay.
sir.
All right. Now try to finish it off quickly so that before the internet connection gets disturbed again. Okay. So I was saying that HKL unmixed means that either all the three indices are even or all the three indices are odd. Every peak should satisfy this criteria if the material is FCC. All right. अगर सारी peaks इस criteria को fulfill करेंगी, only then you can say that your material is FCC. Clear?
Okay, sir.
Yes, sir.
So we start looking at peaks one by one. First peak, 111. क्या ये criteria को satisfy करती है?
Sir, odd है sir.
सारी odd है, सारी odd है तो satisfy करती हैं. Second peak, 200.
Yes, sir. Even है.
All even तो satisfy करती हैं. Third peak,
Even sir, satisfy.
all even satisfy करती हैं. Fourth,
Sir, satisfy.
all odd satisfy. Fifth,
Yes, sir. Satisfy.
all even satisfy.
Yes, sir.
Sixth, all even satisfy.
Yes.
Seventh,
All even.
all odd satisfy. Eighth, all even they satisfy. Since all the 8 peaks are satisfying this criteria, then we can safely say that our material is FCC. Clear?
Okay, sir.
अच्छा, BCC के केस में क्या होगा कि H plus K plus L is even. अगर सारी peaks इस criteria को satisfy करें कि H plus K plus L is even for all the peaks, then your material would be BCC. Clear?
Yes, sir.
Okay, sir.
और अगर ये केस हो कि कुछ पीक्स इस क्राइटेरिया को एफसीसी के क्राइटेरिया को सेटिस्फाई कर रही हैं, कुछ पीक्स बीसीसी के क्राइटेरिया को सेटिस्फाई कर रही हैं, तो फिर यू वुड हैव सिंपल क्यूबिक क्रिस्टल स्ट्रक्चर. क्लियर?
Yes, sir.
Yes, sir.
So हमारे केस में स्ट्रक्चर क्या है? व्हाट इज द स्ट्रक्चर इन आवर केस?
Sir, FCC.
Very good, FCC. Now, if you say the structure is FCC, the relation between lattice parameter A and R is given to you. A is equal to under root A 8R. Clear?
Yes, sir.
तो अगर आपको A पता होगा, you can find out R. Clear enough?
Yes, sir.
And you also know that DHKL is essentially equal to A divided by under root H square plus K square plus L square. All right?
Yes, sir.
All right. So if you could find out DHKL for any one of the peak, you could essentially find out A. Is this clear to you guys?
Yes, sir.
अगर आपको D111 की वैल्यू पता होगी तो you can find out the value of A, and if you know the value of A you can find out the value of R. Clear enough?
Yes, sir.
All right. Now how do you find out the D values for all the peaks? If you remember 2D HKL sine theta is equal to lambda. Now, lambda is known to you. It has been given to you. It is fixed. For peak number 1, you can find out theta. So for peak number 1, you can find out D triple one because the first peak belongs to triple one plane. Clear?
Yes, sir, clear.
All right. What you'll do is that before you find out A, you will have another column for D values in angstrom or nanometers, whatever. And what you'll do is that you will use this relationship for the first
सर
peak.
कंटिन्यू रिपीट कर दें सर, आपकी आवाज सर पॉज हो गई थी एकदम अभी जो एंगस्ट्रॉम
Alright.
के बारे में सर आपने बोला.
All right. So what you'll do is that, so you will insert between HKL and A angstrom column, you will have another column for D angstrom. And for every peak, 1, 2, 3, 4, you will find out the D values. And how would you find out the D values? You would find out the D values using the relationship 2D HKL sine of theta is essentially equal to lambda, which is 1.54056 into 10 raised to power minus 10 meters. So for the first peak, you know the first peak is triple one peak. So you'll write 2D triple one sine of theta. Theta is 38.43. So you'll divide it by 2. Sorry, 2 theta is 38.43 equals to 1.540 or whatever the exact value, 1.54056 into 10 raised to power minus 10. This would give you the value of D triple one. Once you know the value of D triple one, you would find out the A value calculated from D triple one. All right. Is it clear to you?
Yes, sir.
And once you find out the A values using all the peaks, you would notice that lattice parameter, since it's the lattice parameter, it should be the same. It would roughly be the same for all the peaks, calculated from all the peaks. Whether you use D triple one to calculate it or whether you use D420 to calculate it, the value would be 4.0538 or 4.0541. Almost the same. All right.
Yes, sir.
And once you have the A value, you could use 2 under root 2R relationship to find out the atomic radius. It is always advisable to use the lattice parameter calculated from the peak which has the highest 2 theta angle to calculate the atomic radius. All right.
Yes,
So
sir.
the atomic radius comes out to be 143 picometer, and this belongs to aluminum. Clear enough?
Yes, sir.
सर आई हैव अ क्वेरी सर.
जी जी.
सर की जो सेकंड कॉलम है सर, उसमें आपने साइन स्क्वायर थीटा मिनिमम की वैल्यू क्या ली है?
जो सेकंड कॉलम है, आप इस कॉलम की बात कर रहे हैं?
यस सर.
साइन स्क्वायर थीटा के कॉलम में आए और उसमें चेक करें मिनिमम वैल्यू कौन सी है. मिनिमम वैल्यू इज 0.08. जी, फर्स्ट वन. इसीलिए the ratio is 1 over here.
Okay, sir.
All right.
Thank you, sir.
So, all right, you're welcome. So that's it for today. Kindly try to solve the table yourself, finding out the D values and the lattice parameter values as well as the atomic radius values. Try to solve it yourself and find out the value.